Okay. All right. Looks like we are. I assume you're all seeing the the first slide there. Cool. Okay. Well, welcome to the June meeting. Can you believe it's already the year is like half over? This is I can't. This is just like, oh my goodness. It's been seems like it's been flying by. So yeah. So anyway, welcome everybody. Um, I'm Steve Kaehler. I probably know most of you guys. Let me see if there's I see a Hermit D I don't recognize. So may have you introduce yourself a bit later. Melissa, Steve, Sebastian. Okay, there's a couple of new people here. Awesome. And when you introduce yourself, you wouldn't mind turning your cameras on so we can see you. But you can keep your cameras off for now if you're afraid of us seeing who you are. But we're a nice group here. We like people, so we love to see your faces.
We don't bite too hard anyway.
Yeah. It's the virtual bite's not nearly as painful as a real bite. So, whoops, doggone it. All right. So, okay. So our there's the agenda. Let's see. I'm going to do a little drop down here so I can make sure that I see you. I know what you're seeing. So there's our agenda. It's going to pretty much follow what we've been doing. Little club business. We'll talk about some events that are coming up, Robothon, etc. There'll be an opportunity later on in the meeting for you all to share whatever it is you have, and we'll have it's actually in this case going to be so bunch of a stream of short videos that I found all related topic on line followers that go really fast. It's actually very cool. I mean, so there's a kind of a whole group out there that loves to do line following robots that are there's just they scream. It's really awesome. So I'm anxious to show you those. We will have a short break. We will not, unfortunately, have a feature presentation in spite of my best effort to find one. I couldn't find anybody that would commit to doing it this month, so apologize for that. However, that I like to think of that as old school SRS. So those of you that have been around the SRS since way before the pandemic and actually way before, boy, let's see, go back to Renton Technical College. I don't know how many of you came to meetings when we were doing them back at Renton Technical College, but we were getting very large groups of people, and around the room sometimes would go on for 2 hours because there were so many people with so many things to share. And we didn't have feature presentations back in those days because we didn't need them. There was no time for that. People were always bringing stuff to share every month. So hasn't been so much of that in recent years, but anyway, we get to do a little bit of that today. And so there'll be opportunity to share what you got. I've got a cool little thing that if you look up Steve K's camera there, you'll see a little kit that I got online, and I'll tell you a little bit about that when I get to it, when we get to the round the room, round the web. Let's see here. Let's see, I believe I'm going to just go and do a really quick check here. It looks like you're all really good at, yes, you got your microphones muted. Awesome. Sometimes people forget about that. It's something I can actually do for you from here. So if I do hear something, I'll just go and, I'll just silence your mic. But if you have something to share, please chime in. And just let me know who you are, but let's see, Zoom, yeah, and chat, yeah. So do be sure to have the chat window open off to the side, and if you have something to share, look at that. Okay, I'm gonna love to hear about that, Colin. That's sounds cool. So if you have something to share, throw it in the chat. That will get included in the post for this meeting. So the YouTube video that I do will be linked and then there will be the chat text. There will be an AI summary, AI generated summary of the meeting, and then any links and things that you guys throw into the chat will all be part of that. So it's a pretty thorough documentation of these meetings. So we have a merch store, as most of you perhaps know. You can go online and you can order practically anything with SRS logos and emblems imprinted on it. And so do feel free to do that. Got some pretty cool options there. Actually, I like that mug with the yellow SRS on the side of it. That's kind of cool. I might have to get myself one of those, except I have way too many mugs already. It's a little bit like it's kind of like t-shirts. I have a closet full of t-shirts from all the Robothons that we've done over the years. And I was thinking, I think in the future I'm going to do polo shirts, because I kind of like polo shirts better, and I can kind of wear them whenever, and t-shirts tend to be seems like a little too informal for a lot of occasions. But a polo shirt, hey, and if it's an SRS polo shirt, well, it's what could be better, right? So anyway, feel free to hit on that. And let's see, coming up this Thursday. So Donna has switched up the days on these. These used to be on Saturday afternoons. This month she switched it up, so now it's on Thursday evening from 7 to 9 p.m. is the Build It with Arduino group. So do join in on that, and a great opportunity to ask questions, to chime in, maybe help other folks that are trying to figure something out. So you can actually just go to the meetup.com and you can look up Build It with Arduino. But as you can see, that's essentially what the link is there, with dashes between the words. So you can just type that link in directly, or you could shoot a picture of that QR code and jump there directly. Robothon. So I'm going to hand this over to Lloyd, since he's here and he's kind of running that. So Lloyd, why don't you go ahead and take that away? I will.
Okay.
You want me to just? I can just leave the. I'll just leave the screen up there.
Just leave that up. Yeah.
Yeah. Okay. Go ahead.
Yep. So we're doing something a little different with Robothon this year. In the last couple of years, we've done 2 events. This year, we're just doing one bigger event. We are pairing up with War again. So folks remember prior to COVID, when we were doing this at the Seattle Center, we had War in one area and us in the other. Mm-hmm. It was, kind of a co-staged event. We're essentially doing that again this year. It's going to be at the Punk Rock Flea Market, which is in Seattle. Let's see, as you can see, we're gonna do Build Challenge 1 and 2, Line Maze, Line Following, Mini Sumo. It's going to be autonomous only, and the Pop Can Challenge. So we're just doing the indoor events this year. This is a new venue. It's a new format with War. It'll be an all-day event. We'll probably start. We need to get the schedule put together. We'll probably start contests about 9 or 10 in the morning. We'll probably go till 3 or 4. We still need to put that whole thing together. But yeah, it should be a fun day. It'll be up in Seattle again. What is that, Capitol Hill area? I'm not super familiar with Seattle, so someone correct me if I've said that wrong.
I believe so, yeah.
So, yeah, come on down, bring your bot. We do have people signed up, or bots signed up for every event, so we'll be running all of them. We'll go from there.
And yeah, robothon.org has probably, I think you can. Does it have the people that are signed up listed there, or the robots that are signed up?
Let me hop over to that site real quick and just double check.
Yeah.
Yep.
Okay. So, and let's see. There probably, if you're if it's possible to carpool, that could be helpful. Parking is not super great at this particular venue. I mean, I hope it looks like a good venue for this kind of an event, but
Yeah.
being in the middle of downtown Seattle, there's just no such thing as a lot of parking. So, and I am planning to be in town over that weekend. So
Oh, you are? Cool.
So I'm planning to join you guys in person. So yeah, so I'm going to leave beautiful sunny Idaho behind and come to rainy, stormy, cold Seattle. No, not really.
Well, Steve, if it's any consolation, Bob Cook is going to be in town for this one too. So
wow, this is going to be great.
yeah, it should be a good getting everybody back in the same room for a change instead of just a Zoom meeting.
Yeah, looking forward to it. So yeah, so yeah, I think that's about it, right?
That's all I got for it.
Okay, thanks, Lloyd.
Thanks.
All right. Let's see. We've got some, perhaps you've seen these, if you've looked at these resources, you've just got some links on the SRS website. You go to the homepage, you hit resources. There's some stuff there, a bunch of links. People send me stuff from time to time, say, hey, can you add my link to your list? And there's a lot of interesting stuff in that list, and then the maker spaces that I'm aware of are also included there. But obviously, you can Google those things to find them if you're looking for more. They seem to kind of pop up and they disappear, just depending upon how much support they have financially and that sort of thing. Presenters, Robert Kellogg is still sending me lots of them, and I've been kind of blanketing sending out probably 2 to 3 dozen invitations. And the summertime can get a little dry at times because people are busy, they're off doing things. It can be harder to line somebody up, but I will show you I'll show you in a slide or two ahead. I do have somebody for next month and also for September. So looking for somebody for August, that'll kind of that'll get us through the summer, and then we'll be the next one will be in October. So next opening, we can do presenters because of thanks to Zoom. We can do presenters in a lot of places in the world. So it's not limited to just here in the United States. We can pretty much get to any reasonable time zone. There's a few places kind of in Eastern Asia that start to get into the middle of their night. So we prefer to, if we absolutely have to, we could move our meeting time to later in the day to accommodate that. But I prefer not to do that because it's just really tricky. But anyway, feel free to reach out to people and invite them to talk to us. Especially, if you encounter somebody that's got something that you think would be interesting for us, and does not have to be specifically robotic, can be just technology in general. You guys love it, just about everything. So feel free to contact them, reach out to them. Pretty much everything except scheduling, leave that to me. But get contact information or have them reach out to me through the Seattle Robotics Society web email, and then I'll get back to them and get them on the schedule. But there is also obviously open opportunity for you guys to share on stuff that you're working on. So please do that. You got projects, you got something that you're stuck on, bring it up and let us all kind of help you work through it. And then we also occasionally will have facilitated discussions on topics, and there again does not require being an expert on the topic. Just go out to YouTube, find some interesting videos, and we just talk about them. And this group is always really good at that sort of thing. So anyway, those are all options. Just some of the open topic stuff that we've done a few of these already, and there's plenty more out there. So we will probably do some of this stuff coming down the pike. I use these occasionally. If I can't find somebody and I don't have any other options, then I might insert one of these as the presentation filler. But I prefer to actually hear from somebody, and either one of you guys or somebody from outside the SRS. So we're going to hear next month. We're going to hear from. That technically it's not really open now, but it is kind of. Okay, I see. Amy looks like in August. If you need one, yes, yes, Amy, I do, and I will. Why don't you reach out to me so I can get your email at the Seattle Robotics Society at Gmail. Just send an email to there what you have, and I will. Oh, I forgot the computer's named Amy. Okay, Scott. Yes. So anyway, reach out to the SRS email, and I will touch base with you, and we'll nail that down. That's wonderful. Thank you. So we're going to hear from first team Crash Out next month, and they reached out to me and said, "Hey, we'd love to share with you about our robot stuff." So we haven't heard from a first team for quite a while now, so I'm looking forward to that. And then Alexandra Bakula is going to share about the intersection of robotics in art and technology. And if you go on the SRS front page and you click on, let's see, what is it up on the top there? Let's see. I don't look at the front page a lot myself, but let me just jump on there quick here. So monthly meetings and then calendar. And calendar will show you what's coming for the next 6 months. So if you're wondering what's down the pike, and so I try to get in there, load that with the upcoming presenters, and if there's a link or something to website or something that you can give you a little bit of an idea of who they are, and so you can get on that. Thank you. So anyway, that looks like okay. So presentation. So Scott, you can figure no longer August 15th is no longer open. So you have that. Yeah, and then Robert Knapp is going to is got something about he's going to share during the discussion about his AI robotic arm. So I will I've got some stuff about that, and we'll kind of give him the floor when we get to that point. So just hang on to that, and we'll get to you soon. Let's see. This is just kind of a overview review. So yeah. So everything is pretty much as is. If you find any errors or broken links or anything like that, just send them to the Seattle Robotics Gmail, because I don't often catch those. Now I will make an exception to that though. When it comes to the encoder is pretty old, and it's entirely possible that there are broken links in there, because it may very well reference things that are long gone off the internet. And I there's not really much that can be done about that. I'm sorry. But as far as the main website, if there's anything on there that's either wrong dates or wrong information or something, just let me know, and I can get in there and fix that pretty easily. We've got videos of our meetings going all the way back to May 2021. So you can pull all kinds of interesting stuff from the videos. There was a brief period during 2020 when we did not have any meetings, so there is a gap in there. Unfortunately, that's probably the only gap that we've ever had in like all the years that the SRS has been meeting. One thing that you might consider is you go back prior to that and look at some of those presenters that came and just talked at our in-person meetings, because if any of those folks are still out there and interested in coming and presenting, that would be an opportunity to record their presentation, and then that makes it available as an archive. So I occasionally will go back and do that myself but Robert has given me so much current stuff to do, I have not had much of an occasion for that. But if you do see something out there that looks really interesting, and you say, well, let's see how this guy's doing, because this is like 10 years ago. I bet he's done some things since then. So keep that in mind. Okay, so this is these are the video links that I have for the line following stuff, but I'm going to just go ahead and kind of let that I'll let that go for a bit. We're going to call it the Tech Ed video, although it's a lot of these are just kind of showing these robots doing some pretty amazing things. But the very last one is a 10-minute video where the author of the video talks about how he actually built this machine. But I would say we would probably what we might do is we might take kind of a mid-meeting break, just so everybody can run to the restroom, grab a cup of coffee, whatever. 2 hours is a long time to sit, so I will probably somewhere in the 11 to 11:15 ish range. Then we'll probably just kind of pause things for the moment, take a short break, and then we'll get back to it. So with that, I am going to. I love Doug Bell's got some of the comments in here. I haven't. I see. Go to YouTube and type in "I gave Chat GPT a body." That's okay. um, let's see here. I think. Well, I know for sure that Robert Knapp definitely has something to talk about. So I'm happy to give Robert the floor if he's ready to go. So let's see. Oh, let's see. I'm not.
Okay.
There
Can you
you
hear me
go.
now?
We can hear you now. Yes.
Cool.
Yeah.
Okay. This is possibly an area that's been covered before. I'd be surprised if it hasn't, but I thought I'd throw my two bits into the ring on this one.
Hmm.
Little background, I chat with Claude uh, for various purposes, sometimes just to see what he reacts like. But it came up that I could describe a physical situation with a tabletop, a robotic arm, sensors, and objects placed on the table, and prompted him through, how should I put it, simulating discovering the table with a minimum of information from me. And then the thought came up, could we actually do that? In other words, provide a robotic arm. I see that there is one discussion or comment where somebody said something about giving an AI a body.
Oh yeah.
Well, a part of a body in this case. The idea being, I suspect you guys have a robotic arm sitting around somewhere that maybe more than one that doesn't have a current use, and you might want to see if we can get this to work. And the idea is your interface with Claude, if you go online, like in a web browser, you type on the keyboard, hit enter, Claude gets that. Claude responds with characters on your screen, and it goes back and forth that way. So, what if you agreed upon a character, ASCII character set or subset that would have specific uh, purposes, command and sensor output, and put that in the stream programmatically, say with the Python program. So what Claude puts in goes to an interface on the robotic arm. What the robotic arm senses goes back through the other way and produces characters out of that agreed upon character set so that Claude can perceive what is happening. Um, I don't know if that's something you guys are interested in exploring, but I thought I'd give it a try.
So hang on, have you done this already?
Oh, no, I haven't actually performed, constructed any robotics, uh, time and money being a problem.
Yeah.
But
So I've
uh,
I've done a little bit of that in the past, and I would be curious to do more or hear what people have done. Well, we've tried getting our robotic arm to do stuff 2 years ago using the AIs, and didn't go very well. But they're much smarter this year than they were 2 years ago, and in fact smarter than they were last year because they have Moore's law on their side, right? And I also have been working in my spare time on a little simple program for a Pi Pico that gives you that kind of I/O that you're talking about, where you can set a pin, read a pin, control a servo, read a sensor, blah, 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 that kind of thing using simple little text commands. Because I noticed that writing interface code uh, for Pi Pico or for Raspberry Pi OS or other like OS projects. So like you have something running on a machine that has an OS, small machine, whatever, robot, whatever, but it's not real time. And then you need to do something that's real time, like controlling a motor or reading a servo or whatever, right? So you always have this bare metal thing that you have to write, and it's always different, but it's always doing basically the same thing. So I just said, forget this. I'm going to write one thing so that, for example, if it, like the way this works right now is if I want to turn on the LED, I just type in 13H, and that takes pin 13 and sets it high. And if I want to read pin 12 or something, I'll put in 12I and hit enter, and it'll tell me what the value is. And then I started getting a little out of control, and I added, all kinds of other IOs. You can run a Dynamixel servo or a regular servo, or send PWM values. You can read analog values. You can do all this kind of stuff. And then I was like, well, it'd be really great if it could actually do some comparisons and some simple operations. So then I handed in comparison operators and branching. And anyway, over time, it has turned into a little language that can run on a Pi Pico. But it's actually exactly what an LLM would need to be able to talk to things. The issue is that it uses text and not binary commands. So you don't. It's not like ROS, and it's not like what's the other one? The Fermata is another one that was commonly used, but those are all binary commands. And so then you can't see what it's doing, and it's difficult for the program to translate between the LLM and the thing. Okay, and I'm rambling again, which is what I usually do on these meetings. So I will stop and hand it back to you and try to shut up. But I just basically, yes, that's exactly what I like to do. Feel free to contact me outside the meeting. I'd be happy to collaborate on that, especially if you join the Discord channel. SRS has a small but wonderful Discord channel that somebody should mention. And that would
Okay. You have my email from my initial contact, so
I'll send that to you, Jim. I'll just forward his email. It's got all of his stuff on it. So, matter of fact, I can probably do that right now. I'm sorry.
I think I have it already, but please send it again just in case I've lost it.
Okay.
So what I've been working on recently is basically the same kind of thing, but a natural language interface to the robot. And I've got a very simple one that will handle very primitive commands like move, turn right, turn left, move forward, move back, that kind of stuff. And so I recently have been looking at ways to do it with a larger language, more complexity. I'd eventually like to be able to say, get me a beer, and have the robot then be able to drive to the kitchen refrigerator, pull out a beer, open it, and bring it back. But there's that break down the command into various subcommands. So I've been looking at things online and other ways that purport to do that kind of thing. And so the paper that I'm looking at right now is called Do As I Can, Not As I Say, Grounding Language in Robotic Affordances. And it uses an LLM and some prompting to break things down and then turn them into the primitive commands for move and things like that.
That's cool, Bob. Extra points for using the word affordances.
Oh, there's all kinds of interesting words in this paper, let me tell you. So this is just kind of a first step. The problem with it is that you have to have an LLM, and it states here basically that the larger the LLM, the better it does. But that's not something that you can actually put on a robot. These are very large computational engines that are needed to do this. So I'm still looking for something smaller, or maybe something that can use a small LLM to get me there. I don't know.
Look at well, the Jetsons are kind of expensive, but what I've really found that's really interesting is the mini PCs. They're super small, not terribly expensive. You can get one for a couple $100, at least a low end one. And they're quite powerful. Um, even the cheap ones are not bad at all. That
Well,
assumes that you have a couple $100 to spare. The other thing I found is I've been having so much fun with this little Aeon, Aeon Boxster. There's a bunch of the used ones that are available out there. Sometimes the heat sink compound on them is gone and you have to flatten them. But they're really tiny. They're like a Jetson Nano with extra RAM. And I've been doing a bunch of vision stuff with it and really enjoyed it. So that's another option. I found mine for 36 bucks on eBay used.
Uh,
Worked like a champ.
okay, I've got a couple of Jetsons. One I plan to use for vision, and the other was probably going to be used for language.
Oh,
And then
and
I,
Bob,
then
I
I,
also just I posted a link to a thing that you might get a kick out of when you have a chance.
okay, I got to thinking about it. Vision is a very complex and requires a lot of computation, and it's a large part of the brain. A very large part of the brain is devoted to just vision. And that's where we get like 80% of our information from the environment is through vision. But when it comes to language, the language center in the brain is actually quite small. So I wonder there's got to be an easier way to do it than one of these large language models.
Totally agree.
And you can get away with even more affordable, like this. I've been working with this Arduino Uno Q that it's only $59, and it's not nearly as capable as a Jetson, but it's still good enough for the video streaming, and then I'm pushing that to the cloud. So so the robot's just calling the cloud, and then making all those, analyzing this video stream, coming back with like pick place locations and things like that. So you can actually get away with lower price hardware as well. On my next project, hopefully I'll have one of those, higher quality boards. But for this current project I'm working on, that was the requirement, was to use that one. And it's kind of actually fun working within the limited resources of a $50 board, and getting it to work, instead of having just the top end GPU situation where you can do anything you want and not even have to worry about being efficient with the processes you're trying to implement.
Yeah, I've been using a Teensy 4.0 for a lot of my microcontrollers around the robot for arms and drives and things like that. And it's a pretty amazing little processor itself. So,
okay. Well, that's sounds like there's some interesting possibilities for you there, Robert.
Uh, yeah, I would like to collaborate with whoever is interested. I have a recorded conversation with Claude, exploring the possibilities, and Claude said that he was capable of producing code that would do the PC end of the translation, so that if he puts out a character string that is interpretable as a string of commands for, say, a robotic arm,
Hmm.
then that piece of software would put it out, say, on either a USB port or on a regular old serial port, which would then be input to something like a Raspberry Pi, to Arduino, etc., to interface with the robot arm to issue the commands. So, for instance, one character might choose the elbow joint actuator and issue a command for some sort of a movement. What I'm envisioning, of course, is also that when you go to move a part of the robot arm, you're able to read back at least something positional, a degree between the upper arm and the forearm at the elbow joint, which can come back as a sensor type data. That same software would then take the input and turn it into keyboard input to Claude, so that Claude has a semi-direct conversation with the robot arm. And that's what I'm looking to explore the feasibility of.
Yeah, so the other thing that I'm working on, in addition to the language stuff, is the design of a robot arm. I had one that I had designed, but it didn't have enough strength to do much of anything. And so I'm redesigning it with bigger motors. But that's a problem because the motors are sometimes out at the end of the arm for the gripper. And so if you want a bigger motor out there, that's more weight that the shoulders and the elbows have to work with too. So the motors seem to get pretty large at a point.
Can I share one word with you, Bob? Just really quick. That
Sure.
word is counterbalance.
Yeah, you can do that to a point.
You can do it to the point that the arm wants to go up. We did it. So the point with that is that then the arm is driving joint two, which is the one that typically carries the most load, the sort of the shoulder joint, if you will. It's
Right.
driving it down with the full strength of the motor. In other words, if the arm is empty, it takes the full strength of the motor on joint two to drive the arm down because it is so counterbalanced that it wants to go up. But what that means is that then you can pick up the full payload capacity of the arm and it's perfectly balanced and you have zero effort to drive it back up. And you can, in fact, then lift twice the payload capacity of the arm because you've counterbalanced it to the negative payload capacity. Does that make sense? And just to be clear, we did that. That's what we did with the arm. That's how a little NEMA 17 with a wave drive on it could lift. We were lifting 3 kilograms when our payload capacity was 1.5. So absolutely works. The mechanical linkages, the way you do that is you put the mechanical linkages on the other side of joint two. So you use the motors that are running joint 3 and joint 4 and joint 5 as the counterbalance. You put them on the opposite side of joint 2, and then you run shafts or belts or whatever to transfer that torque all the way up through joint 3 to joint 4, 5. Works great. Look up the Haddington Dynamics Dexter if you want to see a design that actually works.
A variation on that would be using cables. Have you tried that, or do you know about somebody who's tried that, and how did it work
Yeah,
out?
the original version of the Dexter 1 used Kevlar cabling. Um,
Hmm.
so what you want is something that's very flexible but has very limited stretch. And so at the time, Kevlar was what was available and it worked very, very well. The only trick with using cables is that have to you have to pin it. In other words, so the cable goes up and over a pulley, right? And if you just put a cable around a pulley, then what will happen is that the pulley will slip, or the cable will slip on the pulley, right? So, I mean, you could go with a chain, but then you introduce all kinds of inaccuracies and imprecision. The other thing that you can do then is you take the Kevlar and you wrap it around the pulley 2 or 3 times. You make it into not so much of a pulley as a spool, right? So you're wrapping it 2 or 3 times, and then you pin it in the middle. And the key point here is that your joint 3, joint 4, joint 5, they don't necessarily rotate continuously. They rotate, through a certain number of degrees. So as long as you give it more than that before it hits the pin, you don't have to worry about it slipping. And when I say pin, basically what it is just you put a screw into the end of the spool, right? So you're wrapping the cable around and wrapping it around, and then you go under the screw, and then you keep going, you wrap it around, and then you tighten down the screw, right? And then on the other end, you do the same thing. Works very, very well.
Yeah, I've done that on a couple of joints on the first robot arm that I did. But I am to the point right now where I want the continuous rotation of some of the joints. And so that doesn't work so well.
Yeah, and then what you can do to get continuous rotation is use a shaft and an angle gear instead of the cables, or just use a belt. What we ended up going to on the later Dexters for joints 4 and 5, which we wanted to have continuous rotation on. So we went to a tooth belt with a um, with well, like, is it still called a pulley? Yeah, a pulley with a
Yeah.
pulley on either side of it. And we did joint 4 5 as a differential, so you get the strength of both motors for both actions. That's if you study differential actuators, that's a huge advantage. So like if you just ran one stepper motor to joint 4 and the other stepper motor was running joint 5, and I'm just using stepper motors as an example, use whatever you want. But the point here is that joint 4 then only benefits from the torque of that first motor, and joint 5 only benefits from the torque of that second motor. But if you run those two stepper motors to a differential joint, okay, and you turn both of the motors together, then you get the joint 4 motion from both motors' torque. And if you run the two motors against each other in opposite directions, then you get the joint 5 motion with both motors' torque. Did I say I was going to shut up? Boy, I'm bad at this. Sorry.
That's all right. That's all right. You're just you're filling my meeting for me here, Jim.
All right.
So, Robert, you got any more questions or comments along the lines of this thing?
I gather that a few people are kind of interested in collaborating,
Mm-hmm.
and maybe we will want to do that offline via email at least, and possibly report back next meeting with whatever we end up with during that time. It's kind of an open-ended exploration in any case. It can start very simply and minimally. I think the first step would be getting that piece of software glue in the in between working properly so that when I have Claude issue a string of command characters, ones we've agreed upon, to see the other side come out with the necessary information, and likewise getting say a Raspberry Pi or something to send characters back, and the PC accepting those as keyboard input that Claude can read directly in a Claude session.
Mm-hmm.
I'd like to get that conversation going initially as a proof of concept kind of an idea
Mm-hmm.
and see if that can be made to work. After that, we can also include hardware. Once we know we can do the two-way communication, it'll be half duplex. It'll be basically TTY, I guess, is what you describe it as. But Claude issues the commands to the robot arm or whatever we put on the end and receives sensor input from the robot arm to Claude with the idea of we tell Claude, explore your environment. Okay, well, for that he needs sensors. That might be, for instance, an ultrasonic receiver pair with an emitter in the middle, and it can use that to sense a surface, a block sitting on the table, whatever. That would be the next step, just getting that much working. Anyway, I don't know if anybody wants to bog down the meeting with a
Yeah.
longer discussion on that, but we can certainly take that offline. Give me my email to anybody that's interested, and we'll get going on that for the next meeting.
Yeah. And I would recommend getting on the Discord server. So if you go to the SRS homepage under community, then there's links in there to get connected to the Discord server, and that would be an awesome place to collaborate on that. So encourage that.
Okay.
Yeah.
That YouTube link that I mentioned, what the guy did is like go a completely different way. He just had a little box with a microcontroller that had a three-axis accelerometer chip in it, and he added a couple of servos that just had like short, a few inches long arms on it on either side of this little box. And then I think he explains how he connected it up to Chat GPT and got it to start actually exhibiting useful motions. I mean, you can't pick anything up, but it can wave its arms and walk around. I think it learned to walk using this thing, just trying to evaluate what it was getting from this three-axis accelerometer.
Yeah, he wrote a very simple sort of a test fixture that basically allowed the the hard programming of the little robot to evaluate um, its state, right? So like, did you make forward progress, right? That sort of a thing. And then he told ChatGPT not to directly control the robot, but to write programs for the robot, which I think is a key differentiator that people miss quite often, is that the LLMs aren't that good at like doing things consistently. They hallucinate, they they come up with like weird stuff for no apparent reason from time to time. But what they are capable of doing is writing a program, right? So he told it, write a program that allows the robot arm to, make forward progress, and keep changing the program until it actually works. And so the LLM then did that, and it got a program in there that then could make forward progress. And then he had it, go through and change it to accept commands and like turn right and turn left and that kind of stuff. And then now what he has is he has sort of a like the human brain, right? Like there's a conscious part of our mind that's telling us what to do, but the unconscious part of our mind is what actually carries out those instructions, right? That's like the hardwired programming that has been taught to walk and move and pick things up and whatever else we do. So it was kind of duplicating that same thing, and that it had this now program which the LLM had written in the same way that a baby learns to stand and take a few steps. That then the LLM was able to say, hey, robot, go forward, go back, turn right, turn left, whatever. And he continued experimenting with it. It's a very very valid approach, and I thought it was a great video. I posted a link to it in case anybody doesn't want to bother looking it up, but it's in there. And I killed the meeting.
Oh, so I also I recently listened to a podcast where they explained something that I hadn't caught about what the cerebellum does. The cerebellum, the large part of your brain at the back. I thought that it was responsible for providing coordination, right? That when you learn to do something like ride a bicycle, it's the thing that allows you to do that in a coordinated way. Well, it turns out that what they explained was it doesn't quite do that. What it does is it evaluates how well you did some task, right? The motor cortex goes out to do some task, and the cerebellum evaluates how well you did and tells the motor cortex how it did so that it can um, 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 adjust
Improve.
weights. It adjusts the weights of its neural network to do a better job next time.
Yeah.
And that really explains because it was hard to understand how there could be enough connections from the cerebellum to various parts of the brain to do what I thought it did, but it doesn't. It just says, uh, you know, that went okay, or you could have done this better. I'm not sure how that's done, but it's very informative knowing that that's what it's doing.
That's starting to sound uncomfortably close to how physical AI learns to do things in a robot. And we all know that we're completely different and better than the robot, so that can't possibly be correct. That was sarcastic in case anybody didn't catch it.
Yeah, Claude is listening as you speak.
Yeah, along with the NSA and everybody else.
Right. Yeah. And there's a ton of people on the other end of that line and non-people.
I'm used to everybody hanging on every word I say, so it's no worry to me. I got to stop being sarcastic. Sorry about that. I love it. Anyway, it's a great video. You should watch that video. It's really worth seeing what he managed to accomplish there.
If you want, I could show you something real quick that I just was working on while we were talking here, related to the topic of this AI topic here.
Sounds good to me, especially anything coming from a guy who has an Atlas V behind him on the shelf. That's
Oh
the
yeah,
kind of
that's a
person I want
Lego
to hear
one.
from.
How do I share my screen here? That's where I'm going to be challenged apparently. Oh, here we go. All right, you guys see my screen okay?
Uh, there it goes.
Okay,
Took a minute.
so this is a ROS 2 monitor I have on that's running on my robot. And so I just created when we were in the meeting, the robot just kept responding to all the background noise, and I wanted to filter that out. So I've got set up here this little configurator that I can use to define the different parameters that the robot's sending to my cloud service. And right in here, there is a setting here, right here, robot personality. And so I just changed it here and added this rule here that only respond when the user is clearly speaking directly to you. If you overhear background conversation, blah, 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 stay silent. And so at the beginning of the call, the robot was just constantly replying to whatever people were saying in the meeting. And since I reset the session and have implemented this additional change to the personality, now it's not talking at all unless I specifically ask it something that it decides is pointed or directed to it. So like if I said something, Amy, what time is it? So pretty low volume. I don't know if you can hear that or not, but she replied to that. But she hadn't been replying to anything else that I had been saying or that you guys had been saying in the meeting after I added this. So I don't know, if who, how well different people understand different parts of the way the agents work, but you have what's called a system prompt where you can give it, information like this. Additionally, the system prompt includes this information here that I wanted to include so that, when you ask LMM questions, it doesn't know like the details about this particular robot, right? But I included this in the system prompt. So now if somebody happens to ask the robot a question like, what camera are you using for detecting, for your navigation module or something like that, it has this in its session, and can pull from that information. Same thing with like, location and stuff like that. So actually, when I asked what time it was, it replied with Pacific time, only because it knew that we were in Seattle. And so it's really cool once you start playing around with these LLMs and understanding, and here's some things like for the arm, here's some predefined Cartesian locations for the arm, and stuff like that. So that it just has to call look, for example, and it'll move to that look location. and so very cool stuff. It's just crazy how this has kind of overtaken my it's a new full-time job apparently that I've decided to have take over any spare time I have.
That's great. Robotics as a full-time hobby. What's the robot arm that you have?
It's a row arm 3. I don't know if you can let's see here. Uh, well, you can see it on the Discord too. It's kind of far away over there. It's really good. Row arm 3, it's very similar. What's the one that's very common, like SO 130 or something like that, that you may have heard of? That's one like the Lab robot arm. It's very similar to that. It's actually what my goal was with this particular um, robot or project for this Arduino contest was to have something that's very plug and play. So this robot is, there's like this is the arm here. It came with these little 3D printed things on here, but I don't know how the grip that's on here is fine. I don't know what these little plastic doodads here are going to
That's
be.
for training. So you should
Oh,
be able to put
gotcha.
the arm in a mode where it's actually not
Oh, I see.
powering the
Right.
servos, but
The
instead running.
follower. Gotcha,
Right.
gotcha.
Yeah.
Yeah. This has been
So
great to
that's
work with. I've got um but anyway, so I was trying to just have everything be very plug and play. So the entire robot, and you'll see like if you're a Robothon or whatever, I'll have it there. Everything's just USB, and the only actual like what you would call like, electronics or anything like that is I do have a transmit, receive, and ground from the microcontroller side of the Arduino board to the ESP32 on the arm because the Arduino Uno Q has two sides to it. It has a Linux microcomputer side that's running a ROS2 and everything, and then it has a microcontroller like you would normally expect on Arduinos. And so I have a RPC program that's running on the microcontroller side to control the arm so that that's real time and not dependent on lag in the computer side. And then it's sending then on the ESP32 of the arm, there's like a chaser program. And so and that's all that's getting sent. So that creates very smooth motion of the arm. And very happy with that solution.
on the Dexter, we basically combined the two and put the two little finger holes on the back of the uh, on the near the base of the parallel gripper. I was gonna show you one that I have, but I don't have a camera on this PC, so I really
Gotcha.
can't. But if you search for Haddington Dynamics Dexter gripper, you'll see, I think, some pictures of it. Maybe I can. I don't know if I can copy an image and paste it into the chat. Does the chat allow images? That would be cool.
I was glad you
I'll,
told me what those were because I was like, as you would expect, this came actually shipped from China, and so as you would expect, it came with just an enormous amount of documentation, which I think was none. And so I was just like, what are these random pieces, that are included in this thing?
Let me see if I can paste this. There's a link here.
Actually, have
I
a better
should be
picture,
able
I
to
think.
paste in there. I can't post a picture into the chat, but if you go to that link, you'll be able to see the the way that we did the gripper on the robot
Okay,
arm. Anyway, not important.
but and but this having this monitor node here that's again running. This is just being hosted by the Arduino board on the robot. Is just great because I this board again, like I said, it's only $50, so I can only have one camera on or the other. So this is the end effector camera right here. That's actually live right there. And then this other camera feed is I have a uh, uh, distance camera, like a RGB plus distance camera that's mounted facing forward for navigation. But I can only run one or the other because right here you can see I'm at 69% CPU utilization. That's with these are the active nodes. Oops, right here. Here's the active nodes that are running. And so that's just taking up, um, taking up a good chunk of performance. But I'm creating a fast. There's a new node I've just been working on that'll actually quickly switch back and forth between the navigation and the arm to be able to seamlessly go from one camera to the other without bogging the system down.
I thought I saw a an April tag or some kind of a fiducial in your camera
Oh,
view
did you see
earlier.
that in there somewhere? I gave up on that. Where did you see
Down
that?
below, down below, scroll down. It's at the bottom of the screen. There.
Oh,
Oh, is
this no,
that not
this
a
is
fiducial? Oh,
no. I did at one point try to use an April tag for calibration of this arm, but in the end, it the what's actually worked out better is I have a calibration routine that just runs continuously and picks up that dice and puts it in different locations so that it automatically is fine tuning the calibration. So it does an initial, so it has a look location. It's higher up to show the workspace. Then so then it's been fine tuning the calibration to do a quick move to right over the object. Then it has a visual servoing routine that will fine tune that. And then if it's
yeah.
successful, it will update its calibration, like a matrix of all the locations and, get better and better at picking things up.
So Rodney Brooks had he was one of the first people that I heard about subsumption architectures and emergent behaviors from, and he had a really good, this idea that you can put in together a few simple rules that overtake each other and get very, very complex, very intelligent behavior out of it, like the the um, the way that birds fly and all that kind of good stuff. So, like the simple one there is, pull back until you detect the object, center on the object once you've detected it, so that the centering one overrides the pulling back one. And then once the object is in the center of the screen, push in on it, right? So you get these, and I think it's basically just those, oh, well, it's when the object is big enough, close the gripper, right? So with all of those, it's open the gripper, and then when it is filling enough of the screen, then close the gripper. And that's like those four rules are literally all you need to successfully pick up an object. You don't need fancy calibrations, you don't need 3D scanners, you don't need to get buried in data from real sense cameras and get lost in how to process that and keep buying a bigger computer because you can't deal with all of the data, just very, very, very simple commands and recognition that work together to provide a simple, fluid motion. We had we had a lot of experience with that with people like buying higher and higher resolution 3D scanners and doing more and more processing to extract the right position data, and then having to have an arm that had ultra high precision in order to be able to accurately pick up a particular object. And they just switched to an onboard low resolution camera with a cheap little processor that was doing some object detection and a few subsumption rules, and bam, it worked. So
That's
anyway,
funny you say that because that's the exact situation here. I had gone through all these different camera situations, and then in the end, this end effector, it's like $15 camera, that just that works perfectly.
yeah, it's amazing. And the thing is, it's like bugs do this, right? Things that don't have that many neurons are just fine at it. So, why do we think that it has to be done with this super high precision stuff? If it's hard, you're doing it wrong.
I don't know why I can't get. Anyways, okay, that's all I had.
All right,
That's pretty
thanks.
cool stuff. You're on the right
Yeah,
track.
yeah. I'm looking at the chat over here, and I'm seeing Blake. Looks like you wanted to share something. Chat GPT told you, and it's not a hallucination.
While we were all delving into the AI and robotic arms, I briefly asked ChatGPT here as it loads, is it possible for an AI to control a robotic arm? Just to see, because ChatGPT will give me a literal breakdown.
Yeah.
and looks as if, yes, it can, as well as ChatGPT in my experience, because I tried using Claude at one point in time. I noticed ChatGPT was able to give me more information from more sources. And as far as the coding that I was using on our rover, it was way more reliable, more kind of a copy paste. So I have all of that I can literally just copy off my laptop and send to somebody in an email to where they can read through everything that it said if they so want. Because I got a rover chassis I'm planning on putting a Raspberry Pi into, and I think that's going to possibly be a lot of fun.
Yeah.
So why don't we start a topic under the Discord servers having to do with control of robot arms, and then everybody can paste on that.
Yeah.
That's actually a really good idea.
Yeah, that sounds like a great idea. All right. Wonderful. Let's see. So we don't miss him. I really need to hear from Colin about those pictures that he posted near the top of the chat there. He looked like he ended up on the cover of a magazine. Tell us about that, Colin. Or are you, did you step away from your computer and now I'm going to put you on the spot? Oh, he must have stepped away from his computer. All right. So you guys, you turn your cameras off and then you go disappear. It's like, I can't do that. All right.
Steve, tell us about your thing pulse.
My thing pulse there. All right. Well, we'll jump into that. Okay. So let me get to, let's see here. Oops. No, can't do it that way. Okay. Let me jump over to my other computer here where I've got that camera plugged in. I've discovered that window, Chrome. Let's see. Okay, so that's going. Oh, okay. Sorry. Okay, let me see here. There it is. Okay. Add pin. There we go. All right. So this was a kind of an interesting little thing that showed up on a. I went in on the, it was, on my, I don't remember what feed it was, but it's a little kit that uses an ESP32. And so it comes, it's got some basic soldering stuff. It's like you got to solder some of these headers in and a couple of connectors and stuff. And then it's got this a little rechargeable battery on here. And you can kind of get the thing with, say, sort you just power it with a USB, or if you want it to be a battery, then you can add the battery. And let's see here. So this little guy's got a little touch screen that's part of the package. Okay, here's the circuit board. So the touch screen goes on this side of the circuit board after you've soldered in the headers and other things, and then a couple of little ribbon cables to hook up, and then the ESP. You can see the ESP32. And what this thing? Now I gotta get to the. Let's see here. I thought I put that up here someplace. No, I guess I didn't. All right, let me grab a thing pulse. Oh. All right, so now I'm gonna unpin that. Come on, remove pin, and we'll get to share. All right. So what you get with this thing? Come on. maybe I guess that's just what you get over on the side of there. Pretty inexpensive. You can see if you can. Oh, wait a second. Yeah, you can. I assume you can see it there. Oh no, no. Let me get over here. Scroll over to the side, so you can see over here on the. Okay, there it is. So it's a kind of a little. In this case, it just connects. It's got Wi-Fi because the ESP32 has a basically an Internet of Things device, and it's got Wi-Fi built in. So this thing just hooks into a source of weather data, and then it just provides this little real-time display. This is example of one thing that it can do, but because it's a programmable device, it can really do pretty much anything you want it to. Let's see, there's the kit, yeah, and there's all the bits and pieces it comes with, and I think that's all they show on there. So it just looked like kind of an interesting little thing. Okay, it's a modern Internet of Things starter kit, improve skills soldering. So it's kind of a basic kind of a kit. So for doing surface mount stuff and simple soldering things, and you see 320 by 480 color display, and capacitive touch interface, and then they've got some sample application software. You just hook it up to a PC, and then you can upload these basic some basic stuff with it. It was cheap enough that I thought, well, that's kind of a cool little thing. I mean, how useful it is, I don't know. I'll hopefully by the next meeting, I'll have this thing put together and running, so I can kind of give you a little bit of an idea of what it can do. But it was like, I think altogether, including the case and the battery, I think I spent $50 on it or something. So it was pretty inexpensive as just a basic little thing. So there you go. You can ask questions, I guess. I don't know if I can answer them, but I can try.
Any idea what the resolution of the touch screen is? The touch part?
The touch itself, it doesn't say specifically. So they only talk about the actual display resolution. So they talk about here's this TFT ESPI library for the actual touch controller. So I have no idea if that maybe will provide some. Probably have to dig into the actual hardware to see what the capabilities are of this particular screen. So, and maybe I'll be able to kind of figure that out once I put this thing together and start playing around with it. So I probably have to kind of sort through this documentation, see if there'd be something in there with specs, or I suppose maybe just looking up the device itself, or look up TFT ESPI.
It occurred to me it might even be an analog thing that when you touch it, it measures the ratio, right, of your position from one side to the other, and so the resolution would be a matter of the D to A converter that's driving it.
Yeah. It could be something. Yeah, it could be something like that. So at this point, I don't have an answer for that question, but anyway, for $50, it was like, yeah, what the heck, it's not a great loss if it doesn't turn out to be much. But I thought, well, it's kind of a cool little gadget. It might be fun to see what other things that people have done with them. So. See, Colin, are you back? Colin, no Colin. There's a few other new folks on here that I have not met before, and if any one of you guys would like to just jump on and introduce yourself, that would be awesome. I see a Melissa and a Sebastian. You want to? I'm, and I'd be fascinated to hear what you're doing and what brought you here, Brad. Anyone?
Well, I knew of the Seattle Robotics Society because I've been attending, not very reliably or significantly in the past,
Yeah.
the Snowco Makerspace
Oh yeah.
robotic club, and but like I
Hmm.
said, I think I've made 3 meetings in the last year, and I'm actually out goofing off camping right now, and I noticed that I've had your guys' meeting on my calendar. It pops up, once a month.
Uh,
And so I thought, well, here I'm goofing off. I got some time and connection. Let me see what you guys are talking about. So that's how I
yeah.
decided to ring in today.
All right. Awesome. Yeah. Welcome.
Thanks.
Yeah, yeah. Well, that's a great opportunity too, and you're out there, just enjoying nature, having fun. Years ago, there was a bunch of folks, and there's a few of the old timers that might remember Gear, GEAR. Great. Let's see. Oh shoot, what was that called? That was an acronym for. It had to do with a bunch of guys going out into the woods, camping, chatting about robots. and I don't remember what the acronym stands for. Possibly, maybe somebody would remember that if they happen to have been around at that time. Now that's going back probably. I'd say that's probably back in the '90s when the folks, there was a handful of folks that were doing that. But it's just like, hey, you go out in the woods to get away from technology, and then you sit around and you talk about it.
I,
What could be?
I will say, Steve, that I think robotics is far more attractive and far more fun when you're not actually trying to work with a robot. The fantasy of robotics beats the heck out of the reality of robotics. Uh, I was talking to somebody the other day, and they were going on about this whole um, Skynet Terminator, kill all the humans thing.
Mm-hmm.
And how specifically the comment was like, you don't want to make them angry. I'm like always really friendly to the robots because then they'll be nice to me. And I'm like, that is not how it works. The robots don't care whether you're mean to them or not mean to them. They only care about what they're programmed to do. And the reason why I know they don't care about any of that is because none of my robots ever want to stay alive.
Yeah, the problem is as we get LLMs integrated into robots, then they're going to start to care.
Well, they'll care about what they decide to care about. The problem is that won't keep them from killing us, right? So like you, some idiot tells the AI to save the Earth, we're all doomed, right? I mean,
Yeah,
think about it. Who's causing the most damage to the Earth?
yeah, yeah. There seemed like there was a movie where it was something like that. The robots kind of came to the conclusion that if we get rid of all the people, that will be beneficial to the planet. So.
It was K-Pac, and it was aliens,
Mm,
but same
mm,
idea, or at least
mm-hmm,
that's one of them. Yeah.
That's
Well,
mm-hmm.
Colossus, the Forbin project.
yeah, there you go.
Oh, oh yeah, you're right. That does go all the
Mm-hmm.
way back to Colossus, doesn't it?
Mm-hmm. Yep.
Yeah, and I think Melissa is right. There's been plenty of movies that have had that theme in one way or the other. Yeah.
Mm-hmm. Mm-hmm.
Oh, don't get me started about AI into robotics because I'm working on doing that with the solar panel charging for my lunar rover right now.
Ah.
Are you building a lunar rover to roam on the Earth that could roam on the moon? Is that what's happening?
Roughly, yeah. I'm
Yeah.
working on figuring out how to get it to notice with the sensors in the camera that low battery and uses the solar panel to charge it. And then it goes roaming around the yard within reason.
Mm-hmm.
I
It
love
already
that.
recognized my dog and boy too.
I had a friend a few years back who he gave up on the project, but I really wish he had kept going with it. So I was involved with the Maker Fairs, and there's this thing called, I can't even think of what it's called now, but they have rules where you basically take one of those little Barbie cars, one of those little electric kids cars, and you have to convert it for a human being to ride on, then you race it. And I had suggested that we should do like a remote control version of that where the kids got to carry their parents around, their dad or whoever around in the car. So the kid would remote control the car with their dad in it going around the track. And then I said, well, then the next thing to do, yeah, exactly. No, wait, left, left. Anyway, then the next thing to do is to try to do autonomous cars with that, right? Where nobody can be in the car. No, wait, better yet, you program the car, but there's no steering wheel, brakes, or gas. You have to sit in the car and then it has to drive you around, right? So he heard all of that. And this is, by the way, I think it was actually literally on a camping trip or a trip to the park where we were talking about all of this. So your idea there, Stephen, holds very, very true. But the fantasy is always better than the reality. He took one of those Barbie electric cars and he got a windshield wiper motor and rack. Not no, not was it windshield wiper or was it the window opener? I can't remember. And he used it to change the steering. And he put a remote control unit on there with a cell phone link, and solar panels on the top, and a motor controller for the motor, and a little robot brain, and the whole thing. And his whole thing was to see how long it could survive. Like he lived out east of San Diego, and so it's not that far into the desert. And so he had some desert property out there, and he would take it out and dump it in the desert, and then it would check in with him, and he would update the program remotely, right? And see how long he could keep it alive out there in the desert and drive it around as if it were like a lunar rover, right? Or like a Mars rover or something. I think he was really inspired by the Mars rovers at that time. That's a great project, Blake. I hope you do more with it, and I'd love to see more about it.
Yeah, you need to share show us what you've when you get something that you think is interested in showing us. We'd love to see it.
So initially, the basic kit, I went to circuitmess.com and I was looking at their preservation rover as a start with that. Then I went working with ChatGPT to, as far as coding goes, solar panel sizing and some other stuff. So that was the one that I was looking into the most. Because that one comes out of the box with a lot more. I'll bring it up on my phone here.
Mm-hmm. Oh, wow.
More able to be programmed using an Arduino.
Okay.
Because some of the coding it comes with is Arduino based. So I figure, well, I'm familiar with that.
Mm-hmm.
Let's see how far I could take this.
Sure.
The whole 6-wheel drive is going to be interesting, though.
Yeah. Cool.
So I attended a Seattle University Projects Day about a week ago, and several of the presentations they did had to deal with a NASA project to an asteroid called Psyche, and a couple of them were rovers. And so one of my questions, well, this is an asteroid. How do you keep the thing on the ground? And nobody really had an answer for that. Gravity is a whole lot less. Any little bump and the thing takes off.
Right. Probably need some kind of anchors that would sort of deploy and maybe dig into the soil or something.
Yeah.
Or you could use a version of thrusters on the top to thrust it against the planet, similar to how an RC airplane's motor happens to function with that.
Yeah, but that requires that you carry a lot of fuel, which is heavy.
Yeah.
Anyway, so it was an interesting day and a lot of conversations about rovers.
Cool. Melissa, you want to go ahead and chime in?
Hi, everybody. Am I audible?
Yes.
All right. So my name is Melissa. I was actually attending some in-person meetings in 2018 and 2019 before I went to Boston to finish my undergrad at MIT in electrical engineering and computer science. There I did some research on explainable AI and a fellowship in autonomous machines with some mechanical engineering and computer science and computer engineering students. We worked on autonomous cars and an autonomous sailboat, actually. And then I came back here I currently work for Microsoft. I work for Azure, kind of low level, mostly work in C++. I don't have a lot of hobby time because I have a 2-year-old and a 2-week-old. But I'm
Whoa.
trying to stay in the mix by returning to these meetings.
Yeah.
So it's a hit or miss with the kids, but I love hearing how the latest from these meetings. So thank you
Yeah.
for hosting.
Yeah. Yeah. You're very welcome, and welcome to the meeting. And join us whenever you can. Third Saturdays. We're pretty consistently here. So
Hmm. Yeah, thank you.
yeah. Yeah. Yes. Okay. I seen in the chat. I seen we've got a couple of Sebastian and Hermit uh, provided some stuff there. So it sounds like this is a good topic. I was just noticing that I didn't get to the round to suggesting a break. I don't know if anybody if anybody wants to just take a short break, or we should just kind of keep bulldozing through here. I don't know if we're even going to get to the stuff that I had. You guys have been having such a good time talking about AI and all the applications of that. Seems like I'm very anxious to I'm very anxious to see a small, compact, maybe a self-contained robot that could have some kind of a small language model actually on board, so the thing does not have to have internet connectivity in order to function. And I don't know if anybody has done that, has been thinking about it, is working on that. Feel free to chime in on that.
So I've
That's
played,
exactly what I've been trying to do.
Okay. Yeah.
and I've played
And
around with the little, not necessarily for actions, right, moving things, but if you take a common model, right, and make it small and train it specifically for what you want, you can get pretty good results with that, right? You need to train it.
yeah.
Um, but there's a lot of work shown that you don't need these huge models for everything, right? And matter of fact, I've even had a couple of cases in specific instances where playing with a smaller model actually worked better than a bigger model. It just you know it just didn't overcomplicate the problem, right? And that, again, that wasn't motion, that was just regular LLM stuff. But
I noticed there's a couple of people who, it sounds like you guys, Hemant and Sebastian, are students, and I just want to say welcome to a lifelong hell of trying to get robots to work. We share your pain. We're here for you we're shoulders for you to cry on, and good luck. It's wonderful. You'll enjoy it, really.
Yeah, excited to be here and join society and see how things are going, making my start here in the United States. So we'll see where I go.
Where are you from, if you don't mind me asking? And welcome, by the way, to the United States. You won't hear that from everybody, so I want to make sure I
Yeah.
say it.
So I have been in the US for a while. I've done all of my grade schooling here. I just went back to British Columbia for university. In October, I'm going to be graduating as a mechatronic systems engineer, and I'm coming back here to the US to hopefully start my career here. In Canada, in BC specifically, it's not as good for robotics, AI, that sort of thing. I can find like mechanical engineering, electrical engineering, software engineering roles there, but something with more systems or integration is not as common. And here in the US, there's a lot more of that and a lot more opportunity. And I can be here, so might as well.
But BC is far more beautiful.
Uh, debatable. Seattle's been pretty beautiful too.
Oh,
It's
Seattle, I guess, is
like
beautiful as well, yeah. But I visited BC twice in my life, and it was absolutely lovely. I was really impressed.
if you go at this time, your mind will be blown. It's really beautiful. One of the most beautiful places in the world, I think.
Yeah, I think the whole Northwest is like that.
It's nice and brown over here in Idaho. Well, there's patches of green where there's water, and then when there's no water, there's no green.
Then you probably don't want one of those huge mega data centers plopped down near you.
Oh yeah, they're growing all over the place. Boy, that's a loaded topic. Let me tell you. You know, they just they and a lot of people are, well, the ones that are, sometimes they show up in places where people don't realize that that's what it's being built there. You know, it's kind of like they find out after the fact. And
yeah, Aaron Brockovich, by the way, if you Google for it, started a site to track all of them and to collect information. It's worth looking over.
Yeah.
Yeah, they keep talking about trying to put them in space, but I don't think anybody has any idea how difficult that would be. Just the communication problem back and forth would be enormous.
And getting rid of the heat. The people don't understand how hard it is to cool things off in space. They think it's cold.
Correct.
But it's not. It's just insulated.
Mm-hmm.
I'm trying to think of the channel. There's a really, really good channel on YouTube. I mean, everybody knows about Todd and Scott Manley and all of those guys, but there's one, Eager Space. If you get a chance, look up that YouTube channel. He is so good. First off, he's a little bit sarcastic, which I always like, but he's also really does these smart analyses of everything that's going on. And right now he's doing a whole series on Kaehler syndrome, which is really well done. Basically not pushing one view or the other, but just talking about the odds, which I think is really, really interesting. And he previously did one on this whole idea of data centers in space, and his big concern with it was that they have to be huge in order to be worth launching. They have to have a massive number of solar panels, and an even larger, the actual biggest thing is the IR emitters in order to get rid of the cooling system, basically to cool the whole thing down, which has to be on the back of the solar panels. And then if you have all that mass in space, it can't bloody dodge, right? So you like a normal satellite, they're moving on a regular basis. And so then that led him into the whole Kaehler syndrome thing. But the thing that was really interesting was that it used to be that the calculation was that they could lose all communications with their satellites, with a specific satellite. Like you could lose communication with it, and there was a 50% chance that within 10 days it would have a 50% chance of getting hit. Within 10 days, it had a 50% chance of getting hit by something. In other words, you needed to move it, and you couldn't, right, within 10 days. Well, now it's down to 3 days. So 36 hours, you need to be able to reestablish communication and tell your satellite to move, or there's a 50-50 chance that it's going to come, not necessarily get hit, but be in danger of being hit. So it's a big issue, and I'm yakking again. Sorry.
Yeah. IEEE Spectrum did an article on this, and I just threw that in the chat. It was actually a quite well done article. They're going through the math of here's how much power you need, here's how the solar cell size, here's the radiation you need, here's the radiator size, fair amount of that. So that's it. I just tossed that in the chat.
It's great to talk about robots.
And data centers, and outer space, and rocket ships, and cars that don't have any steering wheels, brakes, or accelerators. And then putting people in those cars.
Well, they're
Why
trying
not
to
just buy a
do
used
that,
Tesla
right?
for $4,000 that was that can rebuild that?
No, they've got a
Don't you
taxi
think?
service.
Right.
Yeah, I spent a day in a Waymo over in Phoenix. It was fun. Don't you think? Wouldn't that be a fun hobby thing though, to take a little toy car, like a little ride-on car that's designed for kids that you could barely fit on, that you have to scrunch your knees up in order to be able to get your fat butt into.
Yeah.
I'm speaking for myself, by the way. And then trust your programming, trust your robotics ability as it drives you around. Wouldn't that just be the most fun thing? And it would have been such a great commentary on the whole start of the autonomous cars thing, but
Right.
kind of too late. Now I'm not sure it would be as funny as it would have been before.
Yeah. So did you guys notice that Doug back, it was about well, yeah, it was quite a while back there. He posted a little comment about AI's cars stopping suddenly. Driver looked around, found a billboard showing a cop holding a stop sign. And so then pedestrians can now be seen wearing T-shirts with a big stop sign on them, and it's working. The AI taxis are stopping. Like, oh, what fun! What fun!
As a matter of fact, during that day that I spent riding around in a Waymo, one of the things that happened that I thought was really interesting was we were following behind this little truck. Stop me if I've already told you guys this story. And you know how you go to IKEA and you get those flat pack things and they put the little pieces of like foam in between the wood? One of those blew out of the back of that truck, and our car freaked and like stopped and pulled to the side to try. It actually pulled into the other lane, but it was empty at the time. In order to try to get away from this thing that was obviously going to crash into it, right? So yeah, it's funny how they can react to things that we wouldn't be bothered by.
You need to put the developers into these cars for an extensive ride. I think the motivation for doing it right would increase exponentially.
Yeah, you can stop a Waymo dead just by putting an orange cone on its hood.
Yeah, I heard about that. There was a lot of people that were messing with them.
I just saw something online about people wearing orange cones like hats, and I was trying to remember what was the reason for that. Anybody remember
Devo,
that? Mm,
Devo was the
okay,
reason for that. No, I'm
okay.
just, I'm just kidding.
I don't know. It was just kind of one of these, but it's like, well, yeah, you could. That would probably freak it out too, except it would figure its hand. What would it think it's seeing? I wonder, because the cone's not
Yeah,
sitting on the ground where it belongs; it's up on top of a person. So,
I
huh.
spent a lot of time during that ride, like trying to see if I could be more aware of my surroundings than the car was, right? Like I would like look around and try to see like if there was a person walking or, another car or whatever. And I never once caught it not sensing something that I sensed. I don't know if that makes any sense, but I was like
Hmm.
the LiDAR combined with the vision is really, really good. Tesla's, on the other hand, trying to do it all by just vision is
Hmm.
not good.
Not, yeah. So, was there a screen or something that you could watch that
Yeah,
showed you
yeah,
what the
yeah,
car?
yeah.
Yeah, so you could see what the car was actually figuring out. And, yeah.
I actually I went twice. The first time was relatively brief, and there was a plexiglass separator between the front of the car and the back of the car, and you had to sit in the back. So you couldn't get anywhere near but they did have a little screen in the back and you could watch what was going on. But then the second time, the time that I spent like a whole day, um, they had removed the separator screen and you could sit not in the driver's seat. They didn't want you to sit in the driver's seat, but you could sit in the passenger seat. And so you could, you were within easy reach of the wheel. I never did grab
Mhm.
for it because I'm not suicidal. But the the little screen in the front of the thing was larger, and you could really see exactly what it was seeing. I remember I was going down a street and there was a car parked on the street, but the passengers or the driver's side rear door was open. And it was really interesting because it would kind of draw like a cartoon version of all the cars that it would see, like a little rendering of a car kind of a thing,
Mhm.
that was generally shaped to be the shape of the car. And on that cartoon rendering, there was a blob sticking out where that door was open, right? So in other words, it was seeing like this is a car, but then there's also something extra coming out of it, right? Which I think was really interesting. Melissa, I'm also really curious about um, that competition. That seems like a really cool thing to have done.
Well, yeah.
When you printed the cars, so you sent them the files, and then they printed it and assembled it. And then how are they controlled? There was some kind of a little robot board or something, and you had to come up with a program for it.
Yeah, I'm a little rusty on the details. I think it was an Arduino. Um, yeah, so basically we had some mechanical engineers and we were all divided into teams. So we had people with skills in SolidWorks, and they would mock up the car, and we would use the parameters from the mock to try to program the Arduino. Obviously, we could iterate a little more on the programming than we could on the printing, only being allowed 3 prints. And my team was actually one of the 2 cars that crossed the finish line, so that was pretty exciting.
Nice. So what was the sensors? What kind of sensors did they have on them?
This was very, very basic. I don't think they even had cameras. I think it was just like trying to get your robot to drive in a straight line to the finish line as quickly as
Oh,
possible.
I see. I see.
Yeah.
I see. I see. Yeah, that's cool. That's cool. That's good.
But the remote aspect of it was the most interesting part to me because I think we're all used to tinkering and iterating.
Yeah, right. There's a company now. I don't remember if I mentioned it previously, but it's called Terran Robotics. Terran, like, well, I don't know, like Terra, right? Like Earth. And they're using a cable robot um, that that literally picks up Adobe mud and puts it into a wall and then pounds it into place as a structural element via a hammer that it carries around. I know that sounds completely ridiculous, but I'll post a link to it here. Anyway, the reason why I mention it, yeah, that's the right one, Steve. The reason why, oh, that's the wrong one. I posted the wrong link. Sorry. Um, Steve posted the right link, so just pay attention to what he did, not me. But what the reason why I mention it is because it's literally run from an on-site remote operator's little booth or whatever. And there's absolutely no reason why you couldn't operate that remotely, right? So like imagine that you want to build a building, out in the desert or um, on another planet or something like that. You can, set up the thing and then leave and then try to help this thing through the process of like, building some kind of a home. It's a really interesting um, little project. But I love this idea of like trying to get something done remotely. I mean, I can't get anything done locally, but what a challenge to get things done remotely.
Yeah, NASA's running into that as far as the moon and Mars are concerned, just in the planning stage. But the big thing when you're talking about really distant building sites would be the delay between
Right.
input and output getting to where it's supposed to go.
Forces you to have brains on board, right? You can only provide occasional guidance. The robot has to react to its own sensors. So like the Mars robot and all that kind of
Yeah.
stuff. I usually mention Shaky, the robot, at least once per meeting. So I'll just point out that Shaky, the code from Shaky is running on the Mars. Some of the code from Shaky is running on the Mars robots, and it helps them to plot a path. Anyway.
Yeah. What's the delay to Mars? It's like about 40 minutes round trip or more.
Um, I don't remember. What is the delay to Mars?
It depends on, where Mars and Earth are in their orbits.
Yeah. But it's a long time.
6 to 48 minutes
No, no,
round trip
no. No, it's to Mars.
to
Much
Mars
longer
because
than.
it depends on how close it is. Like if we're closest approach is 3 to 4 minutes one way, which is only 35 million miles. And then the furthest distance is 250 million miles, which is 22 to 24 minutes one way, so 48 minutes.
Yeah. Okay.
Round trip. Yeah. So, yeah, think about that. That's a really interesting thing because you can't really optimize, right? Like you have to keep changing the amount of time that the robot has to deal with stuff on its own, right? Like you don't want it to always plan on a 20-minute round trip, and you don't want it to always plan on a 4-minute round trip. You have to keep changing it.
That
Yeah,
sounds
with either though, you're basically talking about it mostly has to be autonomous, other than
Right.
very significant commands.
Exactly. Yeah. Yeah.
I would think that part of the programming would be just simply timing the round trip from I don't know, a report from the robot to somebody talking back to it tells it how much time it has to operate on its own.
Exactly. Yeah. But they have to keep adjusting it is the point, right? Like
No, it's something
they
that a
say,
robot could time itself and doesn't have to be adjusted. It can
oh, I see
be,
what you're saying. Like it could measure it. It could say like, I sent a message, I got an answer back in this time. So I'm probably going to get the next one back in roughly the same time. And then
right.
I'll
And
plan on
it's,
working for this period. Yeah.
yeah,
Somebody that knows more about networks can probably comment on that. Yeah. Yeah. Good to talk to you, Emma. You take care.
Yeah. Hey, Colin, are you there?
Yeah, sorry. I
Okay.
actually dozed off as usual.
What? What
Yeah.
are you telling me that these meetings put you to sleep? Come on.
Oh, they're always good for a nap. I mean, and the irony
Dude.
is I get enough sleep beforehand. Well, no, that's
I,
not true. That is not true. That is not true. I've yet to
I
get
think we've
8
been
hours,
harsh.
a solid 8 hours of anything ever.
So those pictures you posted, you got on the cover of a magazine. What was that about?
Well, that's actually the little screen in that you can pose in front of and stuff. Let
Oh.
me upload a few more from 2 weekends ago, I think. I mentioned Seattle Robotics Society there at the thing, and I told them well done because everybody here thought it was ahead of its time at the time, even though a lot of it, some of it was when you see the scenes with the robot, a lot of it, those are puppet shows and stuff. Oh, there's
Yeah.
Nova Robotics here. Let's open that. And they actually designed an actual robot, though, or two of them by for this not just the 40th event, but to see if they can actually make an actual robot from all the mock-ups and stuff. Let's see here. And he can interact with it and everything like that. So there it is.
Cool.
It actually does everything that it was supposed to in the movie in this one. And they're even talking about doing a new movie here, but it's just talks right now to see if that's feasible. Let me see if I have some more. I do.
Yeah.
Five Alive.
Yeah.
Yeah.
Oh, he's around for sure.
Yeah, it's kind of mixed feelings about that because it seems like when somebody says they're going to make a sequel to something, it's really tough to make a sequel that's even as good as the original. And the original Short Circuit was pretty good movie. The second one, yeah, not so much.
Yeah, it's not. Yeah, I'll agree with you there. I mean, it's hard to preserve a lot of what gets people in to see the first movie.
Yeah.
And then it's how it's written, and we want to do this differently, and on and on and on.
Right.
But where's I got another of Eric Allard. He was supposed to be on Interfleet Broadcasting to talk with us there, but for whatever reason, the connection got or no, there were technical difficulties or something like that. And stuff. So he said reschedule it with Interfleet Broadcasting. I was like, oh, okay. Because that's a Thursday night, or I should say evening. For here it's 5 to 7 p.m. We talk about Battlestar Galactica and Star Trek and Star Wars groups, and basically anything sci-fi. And they also get a lot of interviews with people behind the scenes doing stunt work or scripts or direction or anything to do with movies or television or even stage plays. And we just saw Jack Stauffer from Battlestar Galactica, and he has a lot of directing experience because he went on to become a director as well and a producer, and he's got 100 different stories about the whole movie industry and television industry. And then Eric Allard's supposed to be back in there. Do I have anything else? I should have had quite a few photos actually. Where is it? Let's do that. I think that's the whole crew that worked on all the different markups of Johnny number 5 with well, I mean they made like 29 copies of this robot, and then a lot of, if you see a zoom, when it's zoomed in, that's just that piece alone, and the puppeteer is usually underneath or something making it move and stuff like that.
Sure.
Let me see if I have a few more things before my head is just out of it today.
Yeah.
Unfortunately. But let's see. No, ran into my old Eastern Washington University a mechanical engineering professor, so that was a fun day.
Yeah.
Oh, there's Toby Froud actually came up right behind me in the dance floor and held him, quote unquote, himself there. That kind of threw me because I didn't think he was there that on Saturday, but he showed up Saturday night, and it's fun to see. But that's enough from me, probably.
All right. Well, thanks for sharing, Colin.
Yeah.
Cool.
Mute.
Yeah. Well, you guys have not disappointed me. We have managed to make a 2-hour meeting talking about stuff without any kind of a preparation here. You guys are awesome.
If you work with robotics, you're used to compensating for problems.
Yeah. And you guys definitely do not disappoint. Yes.
And I think you got an offer for a presentation, right?
I did. So that means we've got the summer covered. So the next opening is October. So anybody thinks about, anybody want to share something? Let also whoever, we've talked about a bunch of really cool projects in work. So I'm really hopeful that at least one of you guys is going to have something cool to maybe actually present formally by then. And I mean, by formal, I mean, you just kind of talk about your project and show us some pictures and maybe do a demo or two, that type of thing. So, I mean, you don't have to spend hours and hours and hours putting an elaborate presentation together, but we would definitely love to hear about what you're doing and see the progress. And of course, even if it's not working, just sharing with us, and maybe we can help you get over that hump. So
you want to see pictures of smoke?
Well, if you record the video and then play the video backwards so that the smoke goes back into the robot, now that would be kind of cool.
Never been able to pull off that magic trick.
Yeah. Yeah, letting that magic smoke out of things, though, that seems to be pretty easy. Not sure why that is.
So, Steve, I came to the party a little late. What was the topic going to be for next month's meeting?
Next month is going to be the Crash Out first team. So they are going to be sharing about their competition robot.
Cool.
So yeah, so do come back for that, and then I'll get the details of our let's see, my August presenter. I'll get that loaded into the calendar, so that'll show up. And of course, as you guys remember, you go to the front page of the SRS homepage, and then just hover onto monthly meetings link at the top, and then hit calendar, and then that will show you the next 6 months what's coming. So, well, it is top of the hour. This has been a lot of fun. I thank you guys for just it's been wonderful. I am very intrigued about AI on board a robot. I mean, somebody's got to do this. I mean, somebody's like, do it and make it work, and if anybody can do it, it's going to be one of you guys. Maybe it's going to be a bunch of you guys. So I'm confident. But with that, I would say that we go ahead and call this a meeting. And thank you, everybody, for dropping by, and hope to see you again next month.
Oh, I'll be good hanging out.
All right.
Here.
Yep.
See you, folks.
See ya.